Hey guys, it's Reed here, and today's problem is called Wormhole. This problem is a maze with basically teleportation nodes or wormholes that you can jump between locations when they're using the alphabet as the nodes. So, first thing you're going to do, like all mazes, all maze problems, is you're just going to do your char matrix maze. And then additionally for this one, we're going to create a tree map of character integer arrays for our worms. And we also have to get the shortest path, so we'll have the shortest integer stored. Next, we'll just start reading in our data and make sure that's all good. Like that. And then take up the white space and then reset all of our instance variables. Worms equals new tree map. The reason I'm using a tree map here is because it's pretty easy for me just to do characters. I'm going to store them as lowercase characters as the key, and then I'll store it with the rows and columns into the integer array, so I know where the gates or where the wormholes teleport to. Max underscore value. Okay. So instead, traditionally what I would do on mazes, I load it in by taking the string and just storing it to a char array, or converting it to a char array, and then just loading that directly into the matrix. In this situation, because I'm going to have to check every point, instead of loading it directly into the matrix, I'm storing my char array into a separate one called points. That to char array like this. This is so I can go through and process each coordinate and see if it actually has a warp point on it. Then you just have to check. So I'll char let equals points c, and then if is lowercase let. I'm using the static import for character to do it character.is lowercase of the letter, and it will return if the character is lowercase. If it is, I'll do worms.put let comma new integer array with r and c. And hopefully that will compile and work properly. And I'll do maze rc equals let. So there we have that. And now we can call our recursive method. So we'll recur 0, 0, 0, which will be row, column, and the step counter. And then out that print line, let's see what they want the format to be. There we go, escaped. Okay, the wormholes n plus shortest minus 1, because I always add extra integers. You can handle your boundary cases if you want to in your recursive algorithm. I traditionally just have it get handled in my printout method just because it's easier for me just to do it like that. So there is the basics of the main method. Now let's do the recursive algorithm. So void recur, enter r, int c, and then we'll have int steps. And then inside here we'll check if it's in bounds, greater than or equal to 0, c r less than maze.length, c greater than or equal to 0, c less than maze r.length, and maze r c not equal to the pound sign. Then I'm going to do final, okay, that word wrapped, final char let equals maze rc. I'm storing it as a final char so I don't accidentally use it lower down in my code, so I know that's constant. I don't want to ever have to adjust let if it gets set somewhere. Maze rc, I'm going to erase the maze point, steps plus plus, and then if let equals the exclamation mark, which is the final node, I'm going to check and see if steps is less than shortest. Then I know step or shortest equals steps. Then if that's all good, I'm going to go down. Else, if it's a different character, if it's in is uppercase, same static import a character of let, my letter. Then I'm going to get the integer array points equals worms.get to lowercase letter. I'll get that because then it's going to check the capital letters and lowercase letters are pairs. So I'm going to get uppercase letter and I'm going to pull out of the maze the lowercase letters indexes, which you teleport to. And then I'm going to set a Boolean warp, if I warped up here, to true. Warp equals true, so I don't step on the character, because right here what I'm going to do, I'll do this demonstration real quick. If not is letter, so it's a non-letter character, meaning the @ sign or a period, then, or if it's a warp, which means that I've just teleported, so then it can be a lowercase letter, I can continue with the move, and I'll set warp to false here, and then you recur through your recursive pattern. R-1, C+1, C-1. And there we go. And I also have to go up here, and whenever I teleport, I'm going to recur from the nodes that are in my points array. So point 0, points 1, and steps -1, because the teleportation does not count as a step. So since I already incremented it there, don't have to do it here. So when I was saying up here I subtract 1 up there, an alternate solution would be when you go down here and you store it. If you find that, I could decrease steps by 1 in here, but then I'd probably have to do, it's not as easy for me to just say, oh, just subtract 1 off everything and it will all work out perfectly. To me, that's the easier solution, so that's what I'm going to do. Then, after I've done all my recursion, I'm going to go back and reset maze to let, or letter. So there we go. Let's see if that compiles. No, that's not going to work. Java C wormhole.java. Java wormhole. Escaped in 4 steps, escaped in 7 steps, escaped in 36 steps. So there's the solution, and hope to see you in the next episode.